Hello everyone. Let's start for the today's session. There are some question related to this op-amp. After that, I will start the transient circuits questions. Okay, in this question, the op-amp is ideal. Assuming the op-amp to be ideal, then the value of the output voltage is asking the question. In this voltage is okay. But there are three op-amp in this question. You can say this is the op-amp first output. This is op-amp second output. Okay. The 4 voltage applied on the positive terminal of the op-amp first is 2 voltage of the positive terminal is op-amp second. In the ideal op-amp have a infinity impedance at input side. That's why the input current will be 0. The op-amp circuit. If this is the 0, then this current is also 0. It means these two resistances are connected in series. In here in the second op-amp, this is also 0. This is also 0. Then these all are connected in series. Okay, because of the voltage will be same, a virtual short, this voltage also, this node is same as a 4 volt, and this case this node voltage is also same voltage is 2 volt. Okay, then what is the current passing through it? This voltage minus of this voltage. Okay, I want to apply KVCL at 4 volt node. Incoming current is same as outgoing current. Incoming current is V01 minus of 4 volt divided by of 3 kilo ohm is equal to same as this current 4 minus of 2 volt divided by of 2 kilo ohm. You can remove the kilo ohm, simply you write the current in milliampere because of the resistances are in kilo ohm. In this case this is a 2 1 minus of 8 is equal to 4 minus 2 is 2 into 3 is 6. V01 is 14 by 2. This will be a 7 volt. Then this voltage is same as 7 volt. This is also 7 volt, same node. Same thing we can apply at node 2 volt. KCL at 2 volt node. Incoming current is in this case is 4 minus of 2 divided by of 2 kilo ohm. This is equal to 2 volt minus of V02 divided by of 3 kilo ohm. This is 6. This will be 4 minus of V02 V02. In this case V02 is equal to 6 minus of 4 2 divided by f minus 2. This will be a minus of 1 volt. Okay, but in the op-amp you know about this current will be 0 because of high impedance. Both are 0 current, it means there is no current passing through it. Okay, it means this V02 is voltage is same as this node because of there is no current flowing through it. The current is 0 current flowing through it means there is a 0 voltage drop, means same to same voltage appears at this node also, and this is virtual short. This is also V02 which one equal to minus of 1 volt. Okay, this is a 7 volt. We can apply KCL at this node. Suppose A. What is this? 7 minus of V02 divided by of 5 kilo. It will be equal to V02 minus of V0 divided by of 10 kilo. 5 to the 10. This will be 2. This will be 14 minus of V02. V02 is equal to minus of 1. 2 is equal to, this will be V02 minus of 1 minus of V0. 14 plus 2 will be 16. 16 is equal to minus half 1 minus half V naught. In this case, V naught will be minus of 17 volt. This is the output voltage of this op-amp circuit. Simply you have to apply a KCL at every node and assume the op-amp as ideal. It means the input impedance of this op-amp will be infinity. That's why current enters in the input side will be 0. If there is a 0 input current, that's why there is a virtual short between two terminals. Okay, let's try that. This is the next question. Assuming the op-amp to be ideal, then the impedance parameter of this circuit. Impedance parameter, it means Z parameter. If you want to find the Z parameter, it means you should know about the equations Z11 I1 plus Z12 I2 and V2 will be Z21 I1 plus Z22 I2. In this question, asking about the Z21, it means Z21 is equal to V2 divided by of I1 when I2 will be 0. I2 0, it means there is no current through it. If there is no current, this is the current I1. What? Okay, sorry. Okay, you have to find the current I1 and output voltage V2. How can you find? Simply apply the same KCL KPL. You know about the ideal, it means this current will be 0. This current will be 0. Suppose I taken as this is a VA. V2 is here. It means this current is 0. There is no voltage drop here. It means V2 can say V2 is here. Same voltage. Okay. And these two resistances are connected in series. The 0 current is here. Input side, this is V1. This is I1. This is 0. It means these two resistances are connected in series. Then what is the voltage of this one? This voltage is same as this voltage. You can say this voltage is the VA, then this is also VA. Then what is the VA in this condition? VA is equal to, these two are connected in series. It means you can apply the voltage divider, total voltage V1 and 30K divided by up total resistances. Total resistance will be 40. This will be 3 by 4 V1. But you have to find the I1. What is the I1? Simply I1 is V1 divided by these resistances. V1 divided by of 40. Okay. You can say this is question number first, this is question number second. Okay, come to the output port. This output was V2. It with these two resistances are connected in series, and VA is voltage between these two. Okay, what is the VA? Same voltage divider you can apply. V2 total voltage, and this resistance is 20k divided by total resistance 50 plus 20 is 70, and VA is in terms of V1 is 3 by 4. 3 by 4 V1 is equal to 2 by 7 V2. Then what is the V2? V2 is 21 divided by of 8 V1. But in the question is asking about Z21. Z21 impedance parameter. This will be V2 by I1. What is the V2? V2 is 21 by 8 V1 divided by of I1. I1 is V1 by 40. V1 will be cancelled out. This will be, we can say, 21 into 40 divided by of 8 into 1. This will be 105 kilo. Why kilo? Because of all the resistances are in kilo ohm. That's why this current is in milliampere and this voltage will in volt. That's why this resistance is in kilo ohm. Okay. Simply the finding the parameters, apply, write the first equations. These two equations are the Z parameter, and simply say focus on the what is the asking in the question. Z21. Z21 is mainly V2 by I1 when I2 will be 0. Then apply the all thing according to the questions. Okay. Next question is about the transient. Every every energy storing element has some time constant. They does not work suddenly because of they are uh, store some energy, and to release that energy they are taking some time. If anybody have a property to store some energy, then it will release the energy by taking some time. It will take some time to release all the energy or to respond that. That's why the energy storing element have some time constant. These are provided some transient effect on the circuit. In electrical circuit, the transient effect occurs by affecting of the two element, inductor and capacitor, because of these two are energy storing element. This is the inductor, the capacitor, IL, VL, VC, IC. At initial, it means t is equal to 0 plus this circuit behaving like a open circuit. Because of there is not sudden change in the current. If there is no current, it means the circuit will be open. I will be 0, but there are some voltages. This circuit behave like a short circuit. I see current flowing, but there is no sudden change in the voltage. It means if the voltage is 0, and there is a 0 voltage only. There are no change. The 0 voltage, it means we know about the circuit is behaving like a short circuit. At infinity, it means this t is equal to infinity. All about the in DC circuit, not AC circuit, direct current circuit. Okay, don't assume this thing in AC circuit. There is just some frequency. In DC circuit, frequency will be 0. That's why this circuit is behaving like that. At infinity, this inductor behave like a short circuit, because of there is a DC circuit, frequency will be 0. It means frequency is 0. ZL, we know about Z omega L. Omega is 0. That's why impedance will be 0. Short circuit voltage will be 0. In capacitor case, this behave like an open circuit. It will be fully charged. You can say this will be fully charged at time of steady state. That's why this will behave. There is no current passing through it. That's why this is behaving like a open circuit. With ZC, you know about this will be 1 upon J omega C. This will be infinite. Impedance will be infinity. It means the circuit will be open circuit. This is the assumption. Circuit behavior. Circuit behavior. And this is circuit initial and steady state. Like infinity, t is equal to 0 plus and t is equal to infinity. Okay, let's try to solve the question related to this. At t is equal to 0 plus, switch is moved from position 1 to position 2. It means first of all the circuit connected like that, then after t is equal to 0, the circuit is connecting like that. Then the time taken for 95% stored energy in the inductor to dissipated in the resistor. Is asking about the time, for what time period it will be release your his energy to the resistor. 95% of energy. It means the remaining energy only 5%. There are two conditions. You can say this is t is equal to 0. This you can say infinity. This is minus infinity. Okay. Any circuit behaving like that comes from minus infinity to 0, then after 0 to infinity. Just before this circuit is behaving like a t is equal to 0 infinity 0 minus, this is the 0 plus just after this at t is equal to 0. It means if t is equal to t 0 minus, this circuit is behaving like a steady state for this time period, minus infinity to 0. This is also a long time. You can say t minus is the steady state for that circuit. After that t is equal to 0, circuit will be changed. Then the next possible thing is started from 0 to infinity. In that case, this is the steady state for this condition. This is the initial point. Okay, this is the final point. But before the 0, the minus infinity is the initial point, and t is equal to minus of t 0, 0 minus, you can say this is the final point. You can say this is initial, this is the final. This is, in this case, this is the initial, this is the final. It means if I talk about the t minus circuit, t is equal to t minus circuit, it means the circuit will be behaving like a steady state circuit, not a transient effect there. This is a steady state. It means t is equal to infinity, like behaving like a t is equal to infinity. But it is equal to 0 plus, the next circuit just started at t is equal to 0. That's why this is the initial point of that circuit. Why asking like that? Because of some question is really, the circuit will start from t is equal to 0. There is some other circuit which is t less than 0, and at t greater than 0 there is another circuit. That's why I talked about this. Okay. In this changes, t is equal to 0 to minus to 0 plus, which quantity will change, quantity will not change. We know about inductor current. Inductor current is not change, sudden change. T minus to 0. It will be same. That's why you can say this is 0 minus is equal to IL 0 plus. In this gap is very minimum. You can say micro nanosecond also. This gap is very less. That's why the inductor current will not sudden change. That's why the initial current at IL 0 minus is same as IL 0 plus. And capacitor voltage, this is also not sudden change. That's why capacitor voltage 0 minus is equal to same as 0 plus. But VL will change. This will be not same. IC will change. Inductor voltage will change. Capacitor current will change because of the capacitor opposes the rate of change of voltage, not the current. Same thing in inductor. Inductor opposes the rate of change in current, not the voltage. That's why voltage may be changed. This is the C. This is L. This is also C. Don't confuse between them. Inductor current will be same. Capacitor voltage will be same in this time period. 0 minus to 0 plus. Let's try to solve this question. In this question, if the circuit connected here, this will be, you can say, t minus infinity to 0. You can say at 0 the circuit will be changed 1 to 2. This condition is occurs at t greater than 0. Okay, that's why I'm asking I am showing this thing because of the circuit will start from minus infinity to 0. Then in this case, that 0 point, 0 minus point is behaving like a steady state for this circuit. That's why if you want to draw this circuit at t is equal to 0 minus the circuit connecting here at 1 only. Okay, this circuit is connected like that, 10 volt here, 10 ohm here. Okay, but I'm I told you like that if t minus at t minus, it means the circuit will start on t minus infinity to t minus. That's why the circuit behaving like a like a steady state. In this case, in a steady state, you know about the inductor is a short circuit, and you have to find the inductor current. What is the IL in this case? The same thing, 10 volts directly applied to a 10 ohm resistor, then IL is equal to 10 volt divided by 10 ohm. This will be 1 ampere. The same circuit, you can say this is the circuit at 0 minus, same as initial current of the inductor. This is the initial current. If you want to find the initial current of the inductor, then simply apply this circuit, because of inductor does not change, sudden change of the current. It's not allowed to change the current suddenly. That's why in both the condition, current will be same. We'll get the initial current of this inductor. Then you have to find the final current. For the final current, it means at t is equal to next time infinity, next steady state. The circuit is closed at t is equal to 0 here. Then this circuit closed here. This circuit again short circuit because of I talking about the SD state. This is the open because of switch is connected there. This is 5 ohm. This is 10 ohm. Find this current IL in this condition. What is the current IL?
Sir, always we are taking at the final point of t and doing the
Yes, yes,
analysis.
yes,
Okay,
yes.
okay.
Uh, I give a formula for this to find the current simply. Okay. In this current, suppose there is no source, and assume that the inductor have released own energy, whole energy, because of the inductor can't provide the energy for long time period. You know about this is not a source. Inductor uh, simply inductor stores some energy and released in within the some time period. But I talk about the infinity time. Only source will provide that infinity time, not capacitor, not inductor. In this case, this current will be also 0. Then you can say the IL infinity will be 0. We'll get the T is equal to 0, initial current and final current. You can say this is the initial current of inductor, this is the final current of inductor. Then ILT will be IL at infinity plus IL at 0 minus IL at infinity e to power of minus t by tau. This equation we can apply for both voltage and current current of the inductor and voltage of the capacitor. If you find the initial voltage and final voltage, then you can apply this rule to find the actual current at t is equal to greater than 0. But in this case, you have to find the tau. Tau you know about L by R, L equivalent, R equivalent. In a steady state, you know this circuit is connected here. The inductor is simply 5 Henry. But resistor, if you remove this inductor, then these resistors are connected in series. 10 plus 5 is 15. Then R equivalent is 15 ohm. Then what was it tau? Tau is 5 by 15 is equal to 1 by 3. Then what is the current? Final current is 0, 0 plus initial current is 1 ampere, 1 minus final current is 0 e to power of minus t by tau. Tau is meant 1 by 3. Then what is the IL? IL is 1 e to power minus of 3 t. This ampere. But at initial, what amount of energy stored by the inductor? You know about the inductor energy stored? Half Li square. Inductor is given 5 Henry. I well calculated. Initial current is 1 ampere. 1 square is 1 only. This will be 2.5 joule. And what is the E2? Second time half Li square. Inductor is 5 into I in this case is e power of minus of 3t. This will be 2.5 into e power of minus of 60. But in this question asking about the time. For what time this is remove all 95% of energy. Okay, this is the energy equations. That means remaining energy is 5%. Then 2.5 e to power of minus of 60 is equal to 5% of whole initial energy. Initial energy is 2.5. Then 2.5 5%, 5 by 100. Time at 5% energy remain. Only 5% energy remaining now. 95% is released. This will be e power of minus of 60 is equal to 2.5. 2.5 will be cancelled out. This will be 0.05. You can apply ln log. In this case, this will be minus of 60. Apply log. This will be log 0.05. Minus of 2.995. And what is the t? Divide by of 6. 0.499 second. Only this time, it means 0.5, half of the second is taken to release your 95% of energy. Is energy.
So that IL infinity is 0 because like inductor is sorted, right? That's why.
No, there is no
See.
source. No,
Okay.
there is no source.
Okay.
If there is no source, then how the current is flowing?
Yeah. So that inductor is sorted now. So
Ha
that is
ha ha. Then inductor will sort it
okay.
at infinity time. At initial, there is a voltage source. That's why current is flowing like that. Inductor again sorted because of it taken as a 0 minus. 0 minus, it means that circuit is operating like a steady state because of the 0 minus. Then after there is shifting between time 0 minus to 0 plus. At 0 there is a switch to operate the second position. That's why the new position is started from 0 plus just in just after the 0. Because of the inductor sudden does not allow to change the current. That's why the initial current is same as the previous current. Then after the current will be built up again. That current is will be operated in this condition. This current is flowing like that. You can say initially this inductor will be charged. That's after this will be sorry. This will be charged like that. Then after they will be discharging like that inductor. His graph is like looks like that exponentially. This is infinity, this is t is equal to 0, this is t is equal to, and say again infinity. At infinity this will be 0. Suppose if you put this infinity here in this equation, t is equal to infinity, what is the value of il? 0. Put the value 0, then what is the value of il? 1. It will satisfy your equation. This value is 1. Okay, next question. For the circuit shown below, the current response after throwing the switch from the position A to B. This is the IT is asking about this current response when the switch is turned on, uh, closed at position B. Okay,
Sir, can you show me the answer of the before question?
this one.
Yes, sir.
Okay, in this question simply you can apply initial point, final point. Then after you can find the equations, voltage equation by putting the value initial and final.
Okay, sir.
But this case is different, something different. Why I am telling you? Because there is a inductor and capacitor both. First of all, simply apply the initial point t circuit at t is equal to 0 minus. 0 minus, this circuit is closed in this case here. This is a voltage source. What is the inductor? Same thing, inductor will be short circuit. Okay, this will be 20 volt, 10 ohm, IL at 0 minus. I guess simply I write IL. What is the IL in this case? 0 minus, or you can say IL at 0 plus because of the inductor. Simply or simple or resistor and a voltage source divided by a resistor 10 ohm. This will be 2 ampere. Then after it will be shifted to the in this position at t is equal to 0. Suppose in this case you want to apply t is equal to infinity, then what would get? This is the short circuit, this is the open circuit. we can't find the anything. Is the current 0? We can't say, because of the inductor and capacitor, uh, that the both are in the circuit. Then this circuit behaving like a oscillatory circuit. Once the inductor is charged the capacitor, then capacitor again charge the inductor. This will be whole circuit will be going like that in oscillatory nature. Then you can't directly apply the final theorem. Okay, then apply the circuit at t greater than 0. Suppose this circuit is closed in this condition. This is the capacitor. Capacitor is not initially charged. Only inductor will charge. Inductor. Then there is a current inductor with current because of the initial current. Inductor initial current is showing in parallel to the inductor only, not a series of inductor, only parallel to the inductor. But voltage source of the capacitor, initial voltage of capacitor is showing the series with the capacitor. This is, I write this is C and this is L. This current is I, initial current. Simply. Then how can you solve this circuit? A current source parallel with a capacitor and inductor. You have to find this current. It means this current I divided into two parts, C and L. Because of the oscillatory nature, then you can't say this capacitor is behaving like open circuit, inductor will be in short circuit. No. Because of inductor capacitor both are in this condition, then both behaving like oscillatory in nature. Then how can you find? Simply make the circuit like that, a capacitor, inductor and a current source. Apply the Laplace theorem of this. CS, you know about this is the CS. Inductor behaving like an inductance, Ls, and the initial condition of Is 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 by S. This Laplace of this circuit is behaving showing like that. Now you can simply, you know about the S is the simply j omega. Then you can say j omega c, or this one 1 upon j omega c. This is Ls, j omega L, same thing. Now you can apply IC as a current divider simply. Then ICS will be, total current is Is divided by of S. I write S like that because the 5 and S is confusing, that's why. Total current into opposite of this current is Ls and divided by of total impedance Ls plus 1 by Cs. SS will be cancelled out. This will be Ls, this will be S. Take a common of Let's take LC of this one, first one. This will be LC into S square plus 1 divided by of CS. CS is the LCM. This S and this S will be cancelled out. Then you can take a common of LC. This C will be goes to upper side. This will be LC into S divided by of S square plus 1 by LC. LC will be cancelled out. IS into this will be S divided by of S square plus 1 by LC. You know about the cosine Laplace of cos omega t. This will be S divided by of S square plus of omega square. Then we have to make this circuit like that. IS S divided by of S square plus 1 by of root LC square. Same LC is there. Now we can apply the inverse Laplace. Then ICT is equal to IT into IS, same thing. You can know about this is current is 1 ampere. Sorry, 2 ampere. Initial current is 2 ampere. Same current is there. Then this will be 2 into this circuit is a cos of omega. Omega is 1 by root of LC into T. Then what is the 1 by root of LC? Put the value of L and C. Inductor is there. Inductor is 1 Henry. Capacitor is 100 microfarad. 1 into 100 micro 18 10 to the power of minus 6. Then this will be outside is 10 into 10 to the power of minus 3. This will be 100. Then you can say ICT is equal to 2 of cos 100 t. The option, I think here is a option.
So can you revise that Laplace part? Like maybe I forgot.
Okay, everyone.
So that Laplace, can you once revise like what is that concept? I forgot actually.
Okay. Simply Laplace theorem is a conversion of DC circuit to the AC circuit in the network
Okay.
system. And if d by ds, the d by dt is replaced by s, and integration of something is replaced by 1 by s. Integrator, you know about the integrator? PID controller में there is a integrator na, d is a derivative, and that integrator is this one. Integrator 1 by s is same thing, integration of something. Derivative, it means multiplication of s. And then in this circuit you can apply, if in time domain, then what happen? This I and a constant Laplace is 1 by s. If you apply, this is I divided into two part. C, if you take some voltage here, suppose V, then this will be V. In this case, this is the C dc by dt. In capacitor, this is inductor. This is the current, but if you know about voltage, but this is the voltage, this is the current only. Then you suppose take a voltage here V by this one C, and this is divided by 1 by C integration of I into dt, IC dt, this is current, and this is the voltage. This voltage is L di by dt, like that. Then this will happening 1 by SC, and this is happening at the LS.
Okay.
Then every capacitor, if you want to Laplace convert into Laplace, then this converted as like 1 upon j omega c. No, this impedance ZC is j omega c, and j omega c will by SC. Same thing, inductor is j omega L. J omega is the S. So you know about the Laplace theorem. S is j omega simply. This is the SL. Then you can simply replace like that. Capacitor replaced by the 1 by SC, inductor replaced by SL. Then after your circuit is easy to solve, like simply impedance, series and parallel combination. Yes.
What? So that current source is there, no? That will also be coming, sir. Like in when you apply this Laplace.
This is the initial voltage, current voltage. This is the constant. If there is a constant something, then Laplace of the constant is 1 by s.
Okay.
For the Laplace of constant is 1 by s. Laplace of t is 1 by s square. If there is a t, then you can replace as s square.
No, so that current source. How we are?
Current source or voltage source, anything.
Okay, we can put anything. Okay.
If there is a voltage source, then it simply put by Vs by S. There is no meaning of current source or voltage source. This is the constant. I find the constant 2 ampere. This is the constant value. Then
Okay.
yes. Then simply apply the divider rule, current divider rule, and solve all the thing. Cos omega t is S divided by of S square plus of omega square, and sin omega t is omega divided by of S square plus omega square, and constant have 1 by s. Capacitor replaced by the 1 by SC. Inductor replaced by SL. Resistor is, there is no in resistor, there is no frequency. Resistor is same to same resistor. Constant, it means there is a voltage source and current. This is a constant in your circuit. Only I think maximum is this using in your circuit. Nothing beyond of this. Okay.
Thank you, sir.
Next is the given as at t is equal to 0 plus the current I1 is. He's asking about this current, this loop current. This loop current it means this current and this current. Na? We have to find at initial t is equal to 0 minus 0 plus the initial condition. The first we have to find the t minus. What is the t minus at t is equal to 0 minus. At this condition, this switch is applied like that. This voltage and the switch capacitor is open circuit and inductor will short circuit, and this resistor and this capacitor again open circuit. This resistor have no meaning, these are floating. This is the V. In this condition, inductor current will 0 in this branch because of there is no connection. This open circuit is here, open circuit here. But what is the voltage of this? There are two capacitor. What is voltage of this? Both are same capacitance. Then it will be store the same work energy. That's why same voltage is divided into two part. This will be V by 2 and this will also V by 2. Because there is an open circuit. In open circuit there are some voltage, but current will be 0. Voltages have how much voltage is stress on that point is the V by 2, V by 2. V by 2, why? Because of the both half capacitor is same. If there is difference capacitor, that means they are storing different energy because of the whole half CV square. Then voltage is different, the energy will be different. Capacitor will different, energy different. That's why the voltage is also different. In that condition, you have to apply like that. But here is both are the capacitor is same. That's why V by 2, V by 2. This you can say initial voltage, VC initial. Okay, this is current is 0, initial current is 0. But here is a short circuit. In this case, but here is a short circuit. If this is short circuit, that means there is no meaning of this thing. If there is a short circuit is here, then no current is passing through it, any current. That's why this circuit have no meaning. Then whole voltage is applying on this only capacitor. This capacitor voltage will be 0. Okay. But asking about the T initial voltage will be same initial point at T is equal to 0 plus. At T is equal to 0 plus, this capacitor is behaving like open circuit, inductor will be capacitor behaving like a short circuit, and inductor will be open circuit initial point. And this circuit is connected like that. There is some voltage source because of this one initial voltage V, and the capacitor will be short circuit, inductor will open circuit, and this is the resistor. The capacitor will be short circuit, inductor will open circuit. That's why in this loop is flowing a zero current because of this thing. This is the zero current flowing. If same thing asking about this current, there is some current flowing. R. At initial, inductor behave like open circuit and capacitor behave like a short circuit. But at a steady state, both are the opposite. In a steady state, capacitor behave like open circuit and inductor will be short circuit. But here asking the question at the initial point, the current at initial. This current is flowing when this current is something current. But this current is zero because of the open circuit at initial. At initial, this current is the open circuit. That's why there is no current in this loop. This loop have some current, but this loop and this loop have zero current. In the whole current, there is some loop V by 2R. These are connected in series. You can say the I1 in this loop is 0 because there is no current because of this open circuit. Okay, let's go for the another circuit. A parallel RC circuit is excited at t is equal to 0 by closing a switch as shown in figure with the initial condition assumed to be 0. It means the capacitor have a initial condition will be 0. There is no voltage at initial point. Then the value of d2v by dt square, double differentiation of the current voltage at t is equal to 0 plus. First find the circuit at t is equal to 0 minus. In this condition, this circuit is closed by current I, resistor, and there is some open circuit volt capacitor at a steady state. This current is IR, this current is IC, this current is VC at 0 minus. Then this open circuit, whole current is flowing through the resistor, this resistor R. Then what is the VC? 0 minus, same as the VC at 0 plus initial point, and this will be our total current is flowing through it only. Then voltage drop across the resistor is same as the voltage across the capacitor, I into R. This is the initial point. At t is equal to infinity, at infinity RT greater than 0, you can say. Sorry, there is a initial is given as 0 and circuit is not closed at t is equal to 0. T is equal to 0, this is behaving like open circuit. If it is equal to 0, open circuit, then this voltage will be 0. No current because of the switch is closed at 0, not open. This is closed at 0. It means t is equal to minus 0, there is a 0 voltage. And at t is equal to 0, this circuit is closed. And what is t is equal to infinity? Correct. This is closed circuit after that. And then this is behaving like open circuit. Or this circuit at infinity. And basic infinity same as I into R. You can apply a voltage Vt is equal to initial final plus initial minus final e to power of minus of t by tau. What is tau here? Capacitor C R into R, RC, same as RC because of the capacitor is C and resistor is R. Then what is the Vt? In this case, V infinity is I into R plus V0 is 0 minus of I into R e to power of minus of t by RC. You can take a common I into R. This will be 1 minus of e to power of minus t by RC. Then what is the dVc by dt? Simply differentiate this. If we differentiate this, then one is 0, I into R. Differentiation of this one will be minus, and this minus will be plus 1 by RC into e to power of minus of t by RC. Okay, and again differentiation. I into R by RC. This will be a minus 1 by RC again into e to power of t by tau or RC. Okay, this R will be cancelled out. This will be minus of I by RC square into e to power of minus of t by RC. But in the question is asking about dVt by dt at t is equal to 0 plus. It means just a 0. You can put the t is equal to 0. Then this initial point t I is equal to RC square. Then at 0 is same as the 0 plus also. This course given as the parallel circuit cited t is equal to 0. It means at t is equal to 0 it will close. Before the closing there is no voltage at the capacitor end. That's why initial voltage also already given the question 0. Then you have to find the final value is IR. Then apply the formula of this one, find the Vt, then differentiate 2 times and put the value t is equal to 0. Because I will asking about t is equal to 0 plus and 0 is same thing. Because there is a voltage is not changed at the certain the capacitor. Okay. Let's do the next question. The switch has been closed for a long time and it is opened at t is equal to 0. It means it will close before t is equal to 0. The time required for the capacitor voltage to decay half of its initial voltage. Then first of all,
Sir,
yes,
can you show me what is the answer of the previous question?
yes. Simply you have to find the voltage of a capacitor. Then if you get the voltage of the capacitor, then simply apply the double differentiation, and is asking about the initial voltage t is equal to 0 plus, simply you can put the value of t is equal to 0 and find the value uh, of this one. Okay, in this case, first of all, find the value at t is equal to 0 minus the circuit, open circuit capacitor, and resistor is same, there is no energy storing element, 12k, this will be 6k. You have to find first one initial voltage of capacitor Vc0. How can you find? In this case, you can see these two resistors are connected in series, and this capacitor is connected across this resistor. If you find the voltage of this resistor, and that one is the same as this voltage, you can say Vc0 is equal to total voltage 18 into that resistor is 6k divided by a total resistor 12 plus 6 kilo ohm will be cancelled out. 18, 12 plus 6 is 18, 18, 18 will be cancelled out. This will be a 6 volt. Okay, we got the value of initial voltage. Then find the circuit at t is equal to infinity. Save circuit, but switch is open in that condition. This capacitor is there. Twelve k, 6k. At infinity, this is the open circuit. Then what is the voltage? In this condition, 0, because of there is no sources there. Then at infinity, you can say at infinity this voltage will be 0. Then what is the tau? This is the no meaning of this resistor, because of this resistor is out of sources after the t is equal to 0. There is no connection between them. Only this circuit is there, R and C. This is the 6 kilo ohm resistor and capacitor. C is 100 microfarad. You can say 6 into 10 to power of 3 plus 100 into 10 to power of minus of 6, 0.6 second. Okay, what is the Vt? You know Vt is V infinity plus V0 minus of V infinity into e to power of minus of t by tau. V infinity 0, initial is 6 minus of 0, e to power of minus of t divided by 0.6. It means this value is 6 e to power of minus of t by 0.6 volt. Okay. Then in the question is asking the time required. Time required for the capacitor voltage to decay half of its initial value. What is the initial value? Is 6. Then 6 e to power of minus of t by tau, half of 6. 6 divided by 2. We have to calculate time. Then 6's will be cancelled out. E to power of minus of t by 0.6 is equal to 0.5. You can apply the log ln. ln 0.5 is equal to minus of 693. Then this will be minus of t by 0.6 is equal to minus 0.693. Then the value of t is equal to multiplication of 6 only. 4.158 second. That means it will take the 4 second approximate 4 second for discharge the voltage of half of the initial voltage capacitor. Once it will charge at a voltage of 6 volt. Okay. This question asking simply the switch is closed for a long time and it is opened at t is equal to 0. Then it is closed at long time means there is some initial voltage. Then you have to find that initial voltage by taking the circuit at before the t is equal to 0. Before t is equal to 0, you have to find the circuit. Then after you have to find the value of the initial voltage of capacitor, which will is the 6 volt in this case. Then after we have to apply the voltage at infinity, initial voltage and final voltage. After that you apply this formula, you get the value of the voltage. Then in the question asking about the time taken by this circuit to release the voltage of half of the initial voltage of capacitor. Then simply initial voltage is 6 by 2, half of this one, it means 3 volt. The charge on capacitor C1, C2 and C3 for the following circuit. Next question, there are 3 capacitor. We have to find the charge of that capacitor. It will connect it at the DC voltage source of 10 volt. Know about the all capacitor will be open circuit. But you have to find the voltage at every capacitor. Then after you can say the actual charge of that capacitor because of the the capacitor charge Q is equal to CV, capacitance and voltage. Then you have to find the voltage at across the every capacitor. Okay, just I write the circuit. This capacitor is open circuit. Again this capacitor is open circuit. All of the capacitors have open circuit in DC case. 12 microfarad, 10 microfarad, 8 microfarad. This is the C1, this is C3, this is C2. We have to find the voltage. You know about this combination? All these two are connected in parallel. Parallel connection of the capacitor is equivalent capacitor is summation of this capacitor. Then sum of this capacitor C2 plus C3 is equal to 18 microfarad. Okay, then it will be divided into two part, this voltage across these two capacitor and this capacitor. Okay, because of both capacitor are connected in parallel, then voltage will be same, V2 is equal to V3, but here some voltage other. Okay, total capacitor is 18 microfarad. Then same circuit is looks like that. This voltage is V2, V3, this voltage is V1. Capacitor is 18 microfarad, this capacitor is 12 microfarad. We have to apply the voltage divider in capacitor. Voltage divider in capacitor is same opposite of the resistor and inductor. Then what is the value of V1 in this case? V1 is equal to total voltage 10 volt, and then in resistor is same resistance, but here is opposite of this one, and we have to find the opposite of this one is 18 microfarad. Divide by of same total 18 plus 12 is equal to 30. 10 3s are 30 and 3 6s are 18. This will be a 6 volt. If this is the 6 volt, then this will be a 4 and 4, V2 and V3 is equal to 4 volt. Then what is the value of Q1, Q2, Q3? Q1 is equal to C1 V1, C2 V2, C3 V3. C1 is 12 microfarad, V1 is 6, this will be 72 micro coulomb. C2 V2, C2 is this one 10 micro, and voltage across C2 is 4 volt. 10 micro into 4, this will be a 40 micro coulomb. Again C3 is 8 microfarad, but voltage is same as C2. This will be a 4. This will be a 32 micro coulomb. 72, 40 and 32 is the answer. 72, 40 and 32. Okay. This question is nothing. Simply you can apply two capacitor equivalent and then voltage divider in the capacitor. Is same thing opposite of the resistor voltage divider is here. You find the voltages, then simply Q1 is the charge of the C1 V1, C2 V2. Next circuit is given as the circuit switch is in the figure shown below has been in portion position 1 for a long time and then move at position 2 at is equal to 0. Then we have to this circuit at is equal to less than 0, and this circuit is connected to like that at when t is equal to 0. Then is asking about the value of Vc0 and dVc by dt at t is equal to 0. Initial capacitor voltage and rate of change of initial capacitor voltage. Okay. Same circuit you have to find at t is equal to negative for the finding the initial voltage. What is the initial voltage here? This voltage circuit capacitor will be open circuit and inductor will be short circuit. $50 kilo ohm, this is the 20 kilo ohm, this is 25 kilo ohm, this is 6 volt. And another circuit, there is no requirement of this circuit because of there is nothing happening. This is 10 ut. 10 ut is there. Ut is the simply unit step function, which like t is equal to 0 only, and that condition this will be a 0. 1 kilo ohm, this is 4 Henry, and this current is IL, is given in the question already. Okay, this is the circuit. What is the Vc? This is the short circuited, that it means there is no meaning of this one resistor because of the current is flowing through it like that. Then 25 kilo ohm, 50 kilo ohm connected in series, and this capacitor is simply connected across this resistor. Then we have to find the voltage across this resistor is same as the Vc 0. Vc 0 minus is equal to Vc 0 plus same as initial voltage of the capacitor 6 volt into 50 divided by up these two resistor 25 plus 50. There is no meaning of 20 kilo ohm. The 300 divided by up 75. Then Vc initial voltage of this one is equal to 4 volt. Okay. In this condition, inductor initial current is 0 because of this is the 0. Ut is started from t is equal to 0 only, and then this is the 10 volt is given. After t is equal to 0, this is the 10 volt. Okay. Then all the value is asking at t is equal to 0 plus. Then again draw the circuit at t is equal to 0 plus. Suppose if you want to draw at t is equal to infinity, then what happen? This is again, this is a short circuit inductor and this resistor here, and this capacitor have open circuit. Again this inductor have inductor, there is a inductor is short circuited. This is 10 volt, this is 1 kilo ohm, this is voltage VC. Okay, this is the 50 kilo ohm, 20 kilo ohm, 25 kilo ohm, this is 6 ohm. Again this voltage, what happening, this voltage source is provide the current only through this only, because of this is the short circuit. If the short circuit is there, then this voltage will be 0, then VC at infinity it will be 0. There is no voltage at infinity, but you can't directly apply the voltage equation because of the inductor and capacitor both is present in there. If both are present, then can't apply the simply formula T infinity V 0 minus V infinity into e power minus half t by tau. This is formula only for the when the single energy storing element is there. But here VC, capacitor and inductor both are there. If both are present, then go through the question. Question is asking the value at t is equal to 0 plus, then draw the circuit at t is equal to 0 plus. At initial condition, capacitor have short circuit and inductor have open circuit. Then we have to draw circuit like this only. This is the capacitor, inductor is here, open circuit. Then this is a capacitor, short circuit. Again there is an inductor, open circuit. Voltage, this voltage is coming in the picture, 10 volt, 1 kilo ohm. This is IL into 0 only. Oh, but in the capacitor have initial voltage of 4 volt. Then we have to put the voltage source, because of this is the initial condition. As it is equal to just after the 0. Then after this will be short circuit. This voltage is 4 volt is given. Initial voltage we have find already, but you have to find this thing, rate of change of voltage. And you know about the rate of change of voltage, what is? Current in capacitor. It means you have to find the current at initial point. You have to find IC. In this condition, what is the IC? You can apply, this is the current flowing direction, KVL. At loop 1, started from here, suppose 1K into IC, or you can say 1000, 10,000 IC minus of 10 plus of 4 volt is equal to 0. And what is the IC in this condition? 10 minus of 4 divided by of 1000. This will be a 6 milliampere. And you know about the IC is C dVC by dt. This will be at 0 plus. Because of the circuit is initial voltage, initial condition of circuit. This is also 0 plus. Yeah, you can say T is equal to 0 plus is equal to 6 milliampere. Then dVc by dt at T is equal to 0 plus is equal to 6 by C. Capacitor value is given in the question is 0.5 farad. We have to find 0.5 farad. This is a milli. This is a volt per second. Milliampere divided by the capacitor is volt per second. This will be 12 millivolt per second. The final answer. It means Vc initial voltage is already fine. Apply the initial voltage initial circuit. That circuit at is equal to 0 minus. That time switch is connected to the position 1. Then after we find the value of initial voltage. This one is the 4 volt only. Initial voltage is 4 volt. And then asking the question, you have to check this type of question like dVc by dt. This is the initial current. The rate of change of voltage is given in the question, but this is a simply the initial current. If you find the current, then you will get the answer. But sometime this is the double differentiation is there. In that condition, then this condition you have to find the equation of voltage equation. Then you have to differentiate that one 2 times. Then after you have to put the value at t is equal to 0 to find the initial voltage. Okay, but in this case there is a simple asking at dV by dt. dV by dt is in capacitor, you know about the current. IC is dVc by dt. Sorry, C dVc by dt.
Sir, at t is equal to 0 plus,
Yeah.
if you show me that circuit again, yeah,
Hmm.
the 4 volt source will come because that DC 0 plus is equal to 4 volt. After that, again, that short circuit is what, sir?
Where is short circuit?
After the 4 volt,
Because of the capacitor at initial point is short circuit, behaving like a short circuit. No? At initial capacitor is short circuit and the inductor is open circuit. This is open
okay,
circuit.
we put that 4 volt source like that, sir. It was,
You have to put the value of voltage source and current source. If there is a current in initial current in the inductor, then you have to put the current also here.
okay.
Inductor will be having like open circuit, but there is some charge. Then that one is a discharge through the any other element. Because of this the element have energy stored, then they want to release their energy, then they uh, search like the path of the to release the energy, then after it will be 0 because there is no change because of the t is equal to 0 minus is equal to t is equal to 0 plus, because of there is no change because of this very less amount of time. That's why the 4 volt is there, the 4 volt is also there, but it behaving like open circuit short circuit.
Okay, sir.
Yeah, short circuit means it will take the huge amount of current to charge at initially, and this open circuit is means the this want to maximum voltage at that time. to store the energy at initially. It means a high current flow. Okay, everyone, I want to stop here for today. And next class, I will solve another same type of question is next class also there to improve or the problem solving and to understanding the doubt questions. Okay, I have more question related to this only. Tangent based question I'll solve next class. Thank you to all.
Thank you, sir. Sir, I'll request the previous year questions to you today. Maybe in the mail I will send you. If
Okay,
you can
okay,
send me
okay, okay,
previous year questions to just get the pattern, like how it will.
okay, okay. I'll try to send you.
Okay. Thank you, sir.
Okay.